So, hi, this is the second DNSOP session of this week. Just to explain why Shumon is here, Benno is at the NomCom doing the important stuff. So I have Shumon to not be afraid of you. This is like people, I think you've already heard that on Monday. So we don't have to do this again. This is Notewell. You already agreed to all of this when you signed up. So you should be aware of the Notewell. You should read it. You should adhere to it. I'm supposed to wait 30 seconds. Attention, attention. We also have a code of conduct. Again, this is important to us. So if you think you've been mistreated, please contact the chairs or the ombuds team. I don't think this is happening here, but if there's anything going behind the scenes, please reach out. We'd be happy to help. So make sure you are signed into the Meet Echo on-site tool from phone or from the computer. This replaces the blue sheets. Also, this is what I always forget still, use the Meet Echo to join the mic queue. Keep the audio and video off if you are not using the on-site version. And for remote participants, also make sure your audio and video is off unless you are presenting. So agenda. We have a couple of new stuff because we need more new stuff, obviously. After that, we have a session, like a part of the session is called LIAS, and that's for stuff that's mostly ISE, or it's not clear where this belongs to DNSOP, so we'll have to discuss that. And a couple of stuff that's, if time permitting, but you know how it goes with DNSOP. All right. Without further ado, Joe, you're up. Slides. The clicker should work. Yeah.
But I press IC, it's pretty obvious. Okay. So, good. So it's been a little while since we talked about this on the mailing list. So I have a one-slide recap. This whole conversation started when we were talking about .internal. And the concern at the time from some people was, if .internal doesn't exist in the root zone, and it's provably doesn't exist with DNSSEC, then it's possible that somebody in an environment where it does exist, because you're in an internal network, might get confused. There's ambiguity here. Does it exist? Doesn't it exist? This seems messy. And there were various proposals made, insecure delegations from the root zone to some name server or to something. And this led us to think that maybe the problem here is that we want to say there is a potential zone cut, but we don't want to specify the servers, because there is no useful server we could say, for example, in the root zone that serves an internal namespace that is not visible to a normal consumer of the root zone in the general internet. So the idea was maybe we can find a way of saying zone cut exists, but we're not telling you where to. So the way we did that was to use an NSRR set, which has a single NS resource record where the target is just the empty label, is dot in normal ways of writing these things out. The second thought of this is, well, if we specify that a zone cut exists, we can also specify a DS RR set, because we can do that, and we can say, here's a DS record that you can use to validate the other zone. You can't fetch the other zone, you can't get a referral to the other zone that you can use, but if you're in an internal namespace, maybe you could use that. And this allows someone to sign their internal something.internal zone in a way that doesn't require people to distribute trust anchors using all kinds of horrible IT stuff. So that's just a lot of words. So Warren is a co-author, so you'll notice all the examples contain cute animals, because this is the way we do things now. So here's an example. This is the globally visible name server. In example.org, we delegate duckling.example.org to nothing. And this indicates that the zone cut exists. Duckling, the name duckling.example.org exists, but you can't resolve it from where you are. Here's one with puppies. This is a secure puppy. So we have a DS records, a DS RR set here, just one DS RR here. Same example, but this is a signed zone. So in the internal network, it's actually a signed zone. A resolver that caches this will already have the information in its cache to allow it to understand the DNS key that it receives from some future name server inside a corporate network or something. This one's kittens. This is an example in the draft of something that actually doesn't make sense. I mean, I think a normal resolver seeing this would just not use the one that's labeled unusual. It would use the other one. So this is not a zone cut to nowhere. But in the draft, we decided we're trying hard not to make arbitrary changes for corner cases. So this is probably a broken configuration. The DNS is full of broken configurations. Perhaps just don't do this. Or perhaps in the future, there's some way of doing it. Maybe this is an example of protocol grease. Maybe doing this means we're testing whether people can understand the NSRR set, but we're not expecting it to do anything special. But it's mentioned in the draft, so, and it's kittens, so obviously that's important. There are other examples of using the empty label to mean I'm not telling you something. So 2782 SRV, you can use a target of dot, which means that service is not available. You can specify an MX target with a priority of dot, which means this thing doesn't receive mail. SVCB resource record with a target of dot means that service doesn't exist. These are all sort of philosophically compatible with the idea of having a delegation to the empty label. It means the delegation exists, but you can't use it. Similar, at least. The last two are things that I've certainly used before, and I think other people have used. I actually wrote up the mname one just once upon a time, and it didn't go anywhere. But again, mname is mainly used for dynamic updates. If you want a zone that deliberately doesn't want to receive dynamic update traffic, you could specify an mname of dot, and it seems to work. Whether you like it or not is a different question. And rname as well. If you don't want to publish an email address, instead of just publishing some nonsense, you could publish dot, which means I'm not publishing an email address in that field in the SOA record. So this is the camel page. The camel is very happy, or the camel is at least as unhappy as it normally is without becoming more unhappy, because there's no changes required for anything here. This is just a convention. Now, there are potentially some changes required in things like parsers or things that check DNS syntax, or perhaps there are DNS implementations that would complain loading a zone where the name is just dot, maybe. I haven't found one, but I'm sure they exist. So maybe there's some work for somebody to do. Maybe the Cloudflare dash doesn't let you do this. In fact, the Cloudflare dash definitely doesn't let you do this. So that would require some change. But there's no actual protocol changes. If you receive a referral with a dot in it, you don't have to do any special handling. You just have to fail to resolve the dot as a host name. Yeah. So that is the current situation. We wrote this up. The draft is, I mean, I think it's okay. It could probably do with some editing, but the basic idea, I think, is clear. And I haven't received any feedback saying that the idea is not clear in the document. So the question really is this useful? I think we have a couple of examples where it is useful, including .internal, although that's not the sole focus of this thing. So the question is, what should we do with it?
So my question is, when you say no changes are required, have you actually tested all the resolvers?
No, of course not.
So
However, Wes is wandering to the microphone in order to say words of science.
So I've done some preliminary experiments that showed there doesn't seem to be much any damage that I can detect, and I have a much larger experiment that is almost done that I wrote on the plane on the way here, finished writing on the plane on the way here, but I haven't actually run it. So in the next couple of weeks, I hope to do that.
okay, okay. I think that's required to like document what, like how the implementations behave, because there might be some implementation fire up and a query to dots or something, and we don't want to do that.
So I will say, testing all the resolvers in the world is impossible. We know that, but we can at least get a reasonable approach that, we don't believe there's damage.
Florian, so I'm not super worried that this thing will melt down the root, so that's probably fine. I would like to maybe see science on that, but again, that's also fine. While I step to the mic, can you go back? I believe it's slide 3 where you talk about DS. So I had read the draft months ago, and I failed to swap it in. So you have DS and then brackets ... which is in this famous comic, and then the magic happens. So what's the magic, and how do you actually use this for dot internal? I seem to miss that bit.
Oh, I see. So suppose you have something dot internal zone in your internal network, and that's accessible to devices in your internal network because you forward queries there from your resolver that you hand out in DHCP or something. You sign that zone with some keys, then the DSRR set corresponding to that KSK is the thing you publish in the global DNS. So you're publishing the entry point for your internal zone in your external zone. The reason for doing this is that...
Oh, this is not about dot internal. This is about if you want to use this mechanism for something else.
Correct.
This is basically
This
a
is-
trust anchor.
Yeah.
Okay, no, I thought you wanted to use this for dot internal, and I'm using dot internal, and I go to the to IANA. Hey, can you please put this in the root zone? And I will probably tell you no.
That makes sense. I mean, in dot internal, the whole point of that is a bit like RFC 1918. There is no single trust anchor that makes sense, so you wouldn't use it for that.
Indeed.
Yeah.
That's why I was confused. Thanks.
Yeah. Okay. This is more like if you had corp.example.com. Yeah.
Petr Paček, I see. I kind of like it because, as you said, it doesn't require any special handling. And even if the resolver is not aware of the magical properties of dot, it will just go and try to resolve it to AN quad A. And given the TTLs in the root zone, then once a day you will get 2 extra queries. That seems acceptable.
Yeah.
Given the amount of crap root zone is getting anyway, this will be like nothing.
Yeah, and I think also we have examples of this already happening. So we already have queries of this kind going to the root zone. There are already reasons for those record types not to exist. So there's nothing new here. Mark, you had some concerns in Madrid, but we didn't have time to talk about them.
I've got lots of concerns about this because all this is going to do is result in recursive servers pounding on authoritative servers because there's no answer they can cache.
Say that again.
This will result in recursive servers trying. This will result in recursive servers, especially trains of recursive servers, getting back serve fail. You try do this with 2 levels of recursive servers. It may work with 1 level because you're returning serve fail to the stub client rather than NX domain. But you add another layer of chain in there, you have a recursive server which is getting serve fail from the upstream recursive server. And that is just going to be repeated, repeated, repeated. This is bad protocol design. We know how to do a secure delegation or an insecure delegation, and you just say point it back to the servers which serve the parent zone. That works. That gives you an answer which is cacheable and works down chains of servers, recursive servers.
I'm
Okay.
afraid that time is up, so I would suggest to continue this discussion on the mailing list. I think this goes well with what I asked about the implementation. So probably add multiple layer forwarders into the testing.
All right, cool.
Thank you. So next up is, I I believe, Roy.
Hi, everyone. I hope you can hear me.
Yes. Just give me a moment to find the slides. And I'll pass. And you should have a control of the slides.
All right.
It's 15 minutes.
All right. I'm not sure I need that much, but so my name is Roy Arends. I wrote this DNS protocol modifications for delegation extensions to ask the working group to allow a range of types to exist at a delegation point instead of just deleg. And I will go into the reasons why. Most of this has been presented at the deleg meeting in Madrid. So I'm going to skip all this. You know all about deleg, I hope. If not, go to the deleg working group. So I'm going to skip to slide 7. And this is the motivation to do this in the DNS operations working group instead of the deleg working group. There was a request by our ISG int area director to do this in DNS operations because the view was that it was slightly out of scope for deleg itself to ask for more than one type. In short, the request for this working group is, do we allow future extensions to use the same mechanism as currently developed for the deleg RR type? That is, do we want a range of types? Or if we ever want to do this in the future again, we need a new signaling mechanism, just like deleg needed a new signaling mechanism. So that's really the choice that we have in front of us. What's the result of this choice? Now, if this working group decides to adopt a whole range, then I will talk to the deleg draft authors and request them to make sure that a range is allocated instead of a single type is delegated. But I just want to make very, very clear, there's no controversy there's no difference really between this draft about the mechanism, between this draft and the deleg draft. This is not an alternative proposal. This is solely a request to allocate a range instead of a single type. Personally, I rather had done this in the deleg working group, but I don't want to contradict the IESG nor the working group chairs who allow this to happen in DNSOP. So that's the choice we have in front of us: a single type or a range of type. To be clear, the range of type would be 255 types. 256 types, or a multiple of 2, basically. Yeah, that's really it. It's a very short presentation, and I'd love to have feedback. I'm not sure how the mechanisms would work in terms of policy. So if this working group adopts, if this working group adopts this document, then I think the future will be the mechanism stays the same, just for a range of types, and we will work. I will work with the authors of the deleg deleg draft to incorporate a range. I don't particularly care if it's this draft or the deleg draft where this happens, and I don't need to have another draft with my name on it. So I will get out of the way as long as progress happens. Anyway, that's it for me.
So Ray is not in the queue, but we'll make an exception.
Yeah, that's because my Wi-Fi just went offline, so I can't actually join the queue. Seems to be an issue. Anyway, yeah, I'd just like to say I support the concept. I am one of the RR type reviewers. I think it's certainly a good idea to actually possibly have more ranges reserved for particular types of RR, so that generic behavior can be encodified in resolvers and authoritative servers to support those. So I think there's definitely an argument for saying, records that are above at the parent side of the zone cut should be in this range. Also, arguably again, actually, no meta RRs, we have one already. I do recall having some other use case in mind for reserve ranges. So there's possibly also time that this would actually, I think, require a change to 6895 as well, which is the ION considerations for DNS, which is where currently the reserve ranges are listed. So maybe this work could be folded into a rework of 6895 rather than necessarily as a standalone document.
All right, Ray, do you mind repeating this on the list in an actual mail so we can discuss it? I completely agree with you, by the way. Thank you.
Yeah, I could do that. Yep.
Thanks.
All right, does this work? Hey, Roy. So this is Shimon. So I, speaking as an individual, of course, since I'm up here today, I support this work. I do agree that you need to reclassify the range a bit to deal with special types like this, and we should plan for the future. So have not just one, but several of them. You didn't mention it in your talk, but I did read your draft, and I was pleased that you remembered to carve out a range for this from the private use space too. And the reason I mentioned that is because I ran into this issue when trying to deploy the compact denial of existence NX name meta type in the field using a private type. And it turns out there is no carve out in that section for meta type. So it's very hard to fully exercise the entire protocol if you don't have that. So it turns out Mark Andrews and I this week talked about it, and we have floated another draft to try and address this problem. But now I'm going to run directly into Ray Bellis's comment, which is, while writing this, I was thinking, should this be a separate draft, or should it just be an update to 6895, which is the DNS INA considerations, so that the entire RR space classification is just in one document?
Thank you, Shimon.
So, well, go ahead. I'll have a question as a chair. So,
Patrick, I see. I think it makes perfect sense to update the ranges in one place because, I mean, then people can actually find it. But having rules for the ranges as what the INI is supposed to do with them is different topic than the draft is currently about, because we want to allocate one of these. You mean for DELEC we need to allocate a number? You are talking about ranges. I just want to make sure that we don't fall into a trap where the DELEC gets stuck because we are waiting for the document to move the ranges around and process explosion just because we want to do it right. So somehow please make it work.
Petter, sorry, Andre. Petter, okay. I completely agree, and I will go out of my way to make sure not to impede on the DELEC draft process. I think the mechanisms are exactly the same. I will try to focus the work that I'm doing on getting the range allocated. I'm part of, just like Ray Bellis and a few others, I'm part of the IETF, the IANA type, RR type expert group. I will provide feedback for that draft. If that comes up, when that comes up, but I'll make sure that there's no delay.
Yeah, Ray Bellis again. My Wi-Fi's now working. I'm sure that the chairs could work with IANA to make sure that an allocation can be made from a new block of 256, which will then be nominally the one that might be expanded for future use for other parent-side records. So there's no reason that you'd have to hold up, wait for a 6895 biz before allocating for this.
Exactly. This is, sorry, Andrea, I'm just responding to the questions to my thing. I'm under the impression that we can do early allocations, having done so in the past, working with IANA. So it is possible to do early allocations from a specific range. Sorry, go ahead.
So my question as a chair to the group is there any reason, this seems like useful and needed for the DELEC work, and should we just very early call for adoption and fast track this? Because I don't see anyone being opposed to this, and it would make sense to fast forward this. Okay, seems that people who care are in agreement. If there's anyone disagreeing with me, please say so.
Paul Hoffman, something that Roy just said, that for the DELEG working group, we have to make sure that the DELEG record has enough space around it, but not the DELEG-I record. That can't be in the same space. That's supposed to be one that's different. So it'll be sort of funny when we say, you can put the DELEG-I record wherever you want, but the DELEG record has to be here. We just have to, the DELEG chairs need to remember to do that.
Okay,
All right, thank you, everyone.
thank you, Roy. So next up is Dwayne.
Thank you. This is Dwayne Wessels. I'm here to present the draft on multiple algorithm rules in DNSSEC. We have a number of authors on this draft. They're all listed here. So a little bit of background on this. Currently in DNSSEC, there's, in my mind, a little bit of a disconnect between requirements on signers and validators. When there's multiple algorithms for a zone, signers are expected to use all of those algorithms, and validators can use any one of those validation paths. And so we have some changes proposed to make some updates to that. I guess, Paul, you're getting in the queue early. You don't have a question yet at this point, or is that an old hand? Okay. So this draft was previously presented and discussed on the list and whatnot. As far as the authors are aware, the strongest objections sort of came from Mark, which are sort of listed here, that we shouldn't be constantly trying to track what are universal algorithms. But we feel that is already happening with the registry and the updates in RFC 8624 and so on. There were also comments that deployments need to implement and support all the algorithms, but it causes some operational complexities that we would like to avoid or resolve with respect to situations where we have multiple service providers or transitioning from one algorithm to another. There's an issue with, in particular with the root zone, with the trust anchor. It affects the time at which you can publish an incoming algorithm in a trust anchor. And there's also an issue with graceful degradation. So mostly folks seem to be in support of the kind of things that are in this draft. And so we're hoping to move forward and call for adoption. Since the last revision, there's been one really significant addition, which is this section. I forget the number, section 2 maybe. It also has the title, something like sanity check or proof of sanity, something like that. But this is sort of the verbatim text from that section, which we use to sort of make our point. So it is well known that validators must support certain mainstream algorithms that are listed in the DNS key registry, and that validators must accept any valid path. So when a zone uses multiple algorithms, which must be supported, the zone operator can reasonably expect that any validation path will work, even when serving only signatures for one of them, right? So we've run into the case where a mainstream algorithm has been disabled in an operating system as a matter of local policy. And so one of the changes we're proposing is that in that case, the validator still should accept a path using that disabled algorithm and treat it as insecure rather than treating it as bogus, regardless of other algorithms in the zone. So this is kind of, just reinforcing the points that were just made. Again, the zone operator has a very reasonable expectation that the universal algorithms should work and that any path should work. And if it's a matter of local policy, then that needs to fall upon the local resolver that has made that choice, or in some cases has had that choice made for them. So we're proposing some updates to the algorithm rules. Those are summarized here on this little table. Basically, if a zone is advertising support for only universal algorithms, then it is sufficient that one of those algorithms can be used for signing. So that's a change to the signing rules. If the zone uses algorithms that are formally universal, or there is no universal algorithm present, then the zone operator must sign it with all algorithms. So this preserves downgrade attack protection, but still allows, it makes it easier to do multiple algorithm transitions and multi-signer arrangements. That's basically it. We're hoping that you think this draft is ready for call for adoption, because it's not yet adopted, and we're open for questions, discussion.
So thanks for this. My only concern is, and it has been already raised on the mailing list, that it probably would make sense to first adopt and finish Steve Crocker's DNSSEC algorithm lifecycle, and then use that as a building block for your draft, because it would be weird to have them both and each one using different life cycles. So if the working group wants to work on this, I would suggest to either basically decide what to do on the DNSSEC algorithm lifecycle, and if the working group wants to adopt that, then this needs to be synchronized together. The other option would be just drop the DNSSEC algorithm lifecycle, and then this can go ahead regardless. So
yeah, that's a good question. I don't really have a good sense of how much support the other draft has for adoption. I guess it hasn't been presented for a while, but yeah, I agree that it would be very awkward to have. They're a little bit in competition with each other, so we don't want both, obviously. Yeah.
Sure.
Okay, Shimon speaking as an individual again. So, and a co-author of this. So one thing, for me, one of the important questions is the use cases we've outlined that prompted our proposed tweaks to the algorithm rules, whether the working group thinks those are valid use cases. So we've talked, Dwayne and I and a bunch of other people have talked to lots of people, and most of them agree, Mark notwithstanding, that these are valid use cases that deserve some tweaks to the protocol to address, right? So the thornier related issues, like how to relax the validator rules to deal with situations like Red Hat suddenly withdrawing a mainstream algorithm, those, I think I'm not personally wedded to the solution proposed. We can work on those if we have agreement that these use cases are valid and we adopt this draft, right? So that's where I am right now.
I don't know who's next in the queue. Is it Mark? Victor?
Victor.
Yes. From my perspective, the lifecycle draft really isn't in much of a competition here. It is much more theoretical in scope, applying to a much broader range of protocols, and not really concerned with the specific failure modes and operational concerns, really, that this is supposed to handle. This is fundamentally about making sure that one of the mainstream algorithms is always enough, and sites that are using ones that have been removed and therefore would have been enough alone, are, from a perspective of resolve, don't fail horribly. Especially TLDs might fail that way. When algorithm 7, is removed from some implementation and so on. So we're looking at catastrophic failure modes that are plausible, and there's no downgrade issue as such. Following these rules means that when you remove something that your counterparty believes should have been sufficient, it's your choice to remove it, and if the counterparty decided, is negligent in not having phased it out, then they go insecure, their problem. If you jumped the gun, then it's your problem. But in neither case does the zone fail, it goes insecure. And it's a failure of coordination. So we're looking at failure modes rather than the life cycle thing, trying to encourage people to avoid them by very carefully, orchestrating multi-year transitions. Wonderful stuff, but it doesn't address what happens when things go wrong. And this addresses what happens when the life cycle thing doesn't work as intended, right? Which the life cycle thing has no comment on, right? We have a protocol change that says, do the right thing when the life cycle draft is not being followed, if that's what it is. And I think it's much too complicated, frankly. I don't think the life cycle draft adequately reflects DNS operational reality. It's much too sort of academic in its flavor, if I may say so. That's my take.
All right, thanks, Victor. I think we have 2 more in the queue still. Is that right?
We are slightly ahead
Mark?
of time. So.
Mark Andrews, this is going to come back and bite us badly. This is, I want my pony. This draft is just about, I want my pony, really. Red Hat, when they stuffed up removing the algorithm support, they didn't tell developers that removed it. You got serve fail there because the validators tried to actually use an algorithm and they didn't know it had gone away. Rather than the validators knowing it wasn't supported in the library. This is just Red Hat stuffing things up. It wasn't a problem with what we'd specified for DNSSEC, because what we specified for DNSSEC, we expected the resolve validators to know what algorithms were actually supported in their libraries. We were compiling code assuming it was supported because there was no information to us, no way to determine it. It just compiled with no warning whatsoever. So the moment we knew that it was broken, that didn't work, we went and either configured the service to say that it was no longer supported, and then the implementations went and actually tested each of the algorithms at boot time so that it couldn't happen again. But we're going to have, DNS has really long tails of implementations. And we're going to, things are going to come back and bite us by going and doing DNS algorithm management like this. It will happen.
Right, thanks, Mark. So, I mean, I would say that the issue with Red Hat is only one of the use cases that we talk about in the draft, right? There are others, particularly about supporting multi-signers and other things, which I would encourage people to also consider in their feedback. So next.
I've blocked the queue, so just Peter, and please be brief as well.
Yeah, I'll be brief. Peter Thomason. So the Red Hat problem, I think, had 2 components. One component was support was turned off in certain libraries of the operating system. Validators didn't know that, and then they couldn't fail gracefully. So that has been fixed by checking things on boot time. But now what should they do if they have a multi-signer zone and they receive only a signature for the disabled algorithm that the zone owner could expect to work? That's what this is addressing. So this is not the same thing as non-graceful disabling in some library, which has already been addressed. About the long tail of implementation, this only needs to be implemented. It only needs to be implemented when you turn off an algorithm. So nobody actually has to implement any of that proposal if they are not turning off algorithms. When they're turning off algorithms, keep that algorithm thing, if it was a mainstream one, in an array, the number, and if you encounter such a situation, treat it insecure. So global deployment of this proposal is not required. Only when you turn off things, put it in an array. So that seems not too crazy, I think, to expect that it could work. And finally, the lifecycle draft, very briefly, it addresses only single algorithm situations. The problem we're dealing with here arises from the interaction of multiple. It's not covered in the lifecycle draft at all.
A good point, Peter. That's the end of the queue, right? Thank you for the extra time. Appreciate it.
All right. Mark, you're up, I think.
Sorry, can I say one more thing? Mark, I think a year ago you told me about an issue with this proposal in forwarder situations. I don't recall the details. Would you mind writing that up on the list again? Because I'd like to think it through. Thanks.
That applies to everyone. If you are saying comment that hasn't been said on the mailing list, you should do so. Okay. Mark?
Okay. I've come here to talk about private DNS and private OID and the DS record. Paul asked for implementation of private DNS and private OID, and when we did it, we found there was some implementation issues in terms of equivalent behavior. DNS key and DNS and RSig both have extensions for private OID and private DNS, which allows the actual algorithm identifier to appear in the key material or in the signature at the start of it, so you can actually identify what algorithms we're talking about. DS records for non-private type, DS records don't have this, and for non-private types, it's not an issue because the algorithm number specifies everything about the key algorithm that's being used. But for private types, they do not. It doesn't. You get a set of algorithms, and that causes issues in some cases. Part of this is RFC 1034. Says that DS records actually identify the algorithm, and that doesn't actually work for private algorithms. For a DS record currently, you require the presence of the actual key in the key RO set, and where there are scenarios where you do not have the DNS key that the DS refers to in operational scenarios. So this is just showing how it works at the moment. For a non-private algorithm, we know that when you're pre-publishing a DS record, that just works. We know that the algorithms that are in use in this zone are 100, and that's the only algorithm that is there that is of significance. But when we come to a private algorithm, this is an example of a private DNS algorithm type. We have no idea what that second DS record refers to, what algorithm it is. Do you support, if you support private DNS as an algorithm type, so you may or may not support algorithm 1.example, but if you support algorithm 2.example, you have to treat that zone as being secure when in fact it is in all probability, you should be treating it as insecure. So the suggested solution, my suggested solution is to add some new hash algorithm types which specify that the DS record also includes the algorithm identifier at the beginning of the hash, the same way as we do for DNS key and ROSIG. So in this example, we do, if you implement private DNS, you know whether you implement algorithm 1.example or not. So you can make a decision about whether the child zone should be treated as secure or insecure based on the algorithms you actually support. So and the idea is that new DS hash types would also have to do this sort of encoding. We've got some questions about whether we make it require or recommended in private DNS and private OID is there. So if you do this, you have to support these algorithms or not. So that's that. So any good questions? Can we adopt it?
Yes. How does one know which algorithm a private code point actually represents, right? If they're all just private code points and I look at one, this number means something to the person who published it. What does it mean to me?
Yeah, it was a bit hard to hear that, but.
Okay. Do you need any part repeated? I'm asking, are private code points unambiguous, even with the extra byte in front of the DS?
The adding the extra information would make them unambiguous. At the moment, if you have used private OID or private DS, the DS record refers to a set of algorithms rather than a specific algorithm.
But which specific?
Yes, that's what we're trying to fix by adding the code and adding the identifier to the start of the DS record and specifying the validators and signers and add this information when they're signing or generating the DS record.
So my comment would be that bind is probably the only implementation that implements this, the private OIDs. So it is kind of like Mark's pony here, but I think it feels like a bug in the original implementation that probably should be fixed. So I believe this is useful, especially when there's a whole PQC testing ahead of us, so we don't have to like cannibalize some type somewhere. So I would like to have a discussion on the mailing list on this because I find it useful. Philip.
Yeah, just a random thought. If you see such a DS record, and currently there it's a bit ambiguous which is the real algorithm it corresponds. But the next step which you would do is you get the DNS key RR set and you try to figure out which public keys match with this particular DS. Because if you don't find any public key that matches this DS, then you drop the DS. And as soon as you have this DNS key, then you know the exact algorithm that the DNS key represents. So it seems that a minor tweak in how you would process the DNS key RR set could have the same effect, that if you find out in this specific case that you did find the DS, but you don't find any DNS key with an algorithm that you actually support, then you still pretend that the DS record was not there and you just move on.
That works in some scenarios. It doesn't work in all scenarios. What I'm trying to do is make DS work properly in all scenarios.
Maybe you can write to the mailing list and
pre-publish, you can't, it doesn't work when you pre-publish a DS record at the moment.
Yeah, we should discuss that on the mailing list probably to see how it doesn't work. Yeah,
I guess this is
it fails downgrade resistance completely. You can't
Can I stop
decide
you?
whether the DS
Please
is valid
respect
based
Victor.
on.
Well,
Yeah.
you jump into the queue. Sean, you're okay? You're anyway up. The time is up. So thank you. And let's continue this discussion on the mailing list because it seems like there are some things to be hashed out first before we can continue with this. So Florian, you're next.
Okay, so this thing is not clickering.
Oh, sorry. Mouse. Okay.
No, it's clickering. Okay, so let's start with the problem statement. When you run a DNSX signer, you must keep your private keys confidential at all costs, basically. And common solution for that is you use a hardware security module which prevents you from extracting the private key from the thing, or you have some sort of operational policy that says the private keys must not leave the signer unencrypted. Both of these schemes effectively prevent backups. That's kind of the whole point of the hardware security model. Module. You can't have a backup. That's the that's the thing. However, operationally, we do like backups. So what can we do about this? And a compromise usually is you have some sort of secret sharing scheme for your HSM or some other thing where you split your secret into parts, hand it off to a bunch of people. And this is at best annoying. I've seen people operate this, and then you run into the issue. If you want to restore your key, you need to get a bunch of people together. Good luck with that. This already is difficult in an exercise. If everything is on fire, it might not actually work. Also, you might actually get this wrong. How many people do you need together for a quorum? And maybe they're all in your company and they all show up at your Christmas party and something happens there. So then the question is, can we do better? And well, turns out, yes, we can. Martin, my co-author, and me, we were brainstorming this in Madrid, and we talked to a bunch of people, and most of them said, well, I don't know, actually. And one person says, yes, you probably kind of maybe can, but I can't figure out how. So then we looked at this, and so stepping one step back, so once you have signed your zone, it's effectively public data. It's integrity protected. You can just toss it on your normal backups. It doesn't matter if it gets lost. You can't mess around with it anymore. So you have that. Now you lost your private key in some shape or form. Maybe there was some disaster or malicious action. So for example, we operate 2 signers in 2 data centers. But it is possible for someone to get physical access and just smash them. So these are things that can happen. And now, what it turns out, what you can actually do is, if your private key is inoperable, you can still do a key rollover. You can use the 7503 key rollovers. You need to squint right, and the timing considerations are slightly different. And there is a duration where you can't actually change the zone because, well, you lost the private key that currently signs it. You're introducing a new key, which also means that not all the prescribed schemes work. So we figured out which one you can use. And another constraint is your signer must not remove the old R6. So this is what happens in practice. You feed a pre-signed zone into your signer. It has new keys. It says, oh, I don't have keys for this R6. I will just drop it and introduce new ones. Well, you can't do that because then your zone is going to be bogus. So I'm not going to walk you through how this actually works. I don't have enough time, and I'm also not prepared for that. I would just drone on and nobody would understand it, including myself. So the suggestion is, can you please read the draft? And so the next step is we actually need this internally for disaster recovery exercises, and that's what we're actually going to do. So we will try this out in a disaster recovery exercise. And we already asked some signer implementers for some feedback. And well, the feedback was not, you're completely out of your mind, we can't do this. The feedback was rather, yeah, this probably works. So the question for the working group is this something that you're interested in?
Hello, Stefan Ubbing, SRDN. I liked your draft. I read it. Good set out on how you do the things. It needs software changes for most things to keep to error 6, but I support this, and I will confirm this on the mailing list.
Thanks.
Johan Stenstam, I have 2 comments. Comment number 1, why not use an HSM that actually supports backups? At least in this HSM case. Comment number 2, regarding the reference to how to do this that you don't go into detail of. Well, as the original author of the RFC you refer to, I must say that it confuses me extremely. I will have to go and read this very carefully because I simply cannot understand how it works.
Yes, that's the whole point. This is why I did not walk you through it, because it is complicated.
Petr Špaček, I see. I like the inventive reading of the procedures, and I think it should work. For code changes, that sounds easy enough to do. And having said that, it basically doesn't do any protocol changes at all. It's just you follow the protocol with this like squint an eye of eye, and it just works. So I'm suggesting perhaps this is not necessarily an RFC. Perhaps it's like, you know, this is basically how to, and DNSOP might be better place for how to's than, you know, RFCs.
Yes.
For just to consider.
Yes, it indeed doesn't need any protocol changes. However, this is operations. This is DNSOP.
Jim?
Yeah, Jim Reed speaking for myself. I'm rather puzzled by this document and what you're trying to achieve here. I think adding yet more complexity into already very complicated system is generally a bad idea. And I think what you're trying to do is solve a solution that doesn't need to be fixed. What you've got here is something that applies to a specific policy regime that applies in the terms of the fact that you cannot get your keys shared or whatever, but your private keys shared. And that's probably not the general case that people are using for DNSX signing. There are 1 or 2 that use those kind of systems, fine. But as Johan pointed out before, if that's your problem, you can't recover the private key, use HSMs that can actually allow that. But I would go a little bit further beyond that as well and says, in practice, what you're really talking about here is nothing really different from what happens if your master DNS server or your primary DNS server goes down, and we don't document procedures to deal with that.
Okay. Yeah, I wanted also to respond to currently escaped my mind about the use HSMs that support backups. Well, we use HSMs that support backups. The question is, what are you doing if that goes wrong? And so, for example, you have the backups, you have 2 HSMs, maybe you lose both of them. So you need to do better with your backups. Then you can say, oh, I'm doing encrypted backups. Then you kick this basically down the road. What I have seen is HSMs with key cards where people try to do a restore and noticed, oh, a bunch of our key cards don't actually work. So things can still fail, and at some point you're considering, my backups are gone. What am I doing now? Oh, let's go bogus. That's not a good thing. And we also do not have an RFC that tells you how to actually go insecure. This might improve things. Don Ramler.
So I would rather see a BCP on don't use HSMs unless you are root, but. But I agree that this is like this falls into DNS operations, and it should be discussed more on the list because there's no unanimous agreement. But it is falls into the scope. But don't use HSMs.
Thanks.
Peter?
There's one more question.
Sure. Oh.
Hi. I'd just like to point out that this draft actually isn't adding any complexity to the protocol because it changes 0 things about the protocol. It just describes a path forward if you can't use your existing key for how to recover without going insecure. And that is possible today. The draft just describes what the steps are, similarly as other operational practices RFCs that we have already for key rollovers, and that particular case there is missing. And I think it doesn't matter if you like HSMs or anything like that. Like even if I don't use HSMs, it can happen that I lose access to my key for some reason because the police takes my server away or whatever. And then it's nice to have a tutorial for how to fix this under, certain conditions. And that's what it describes without adding any sort of complication. I think it's worthwhile describing.
Okay, thanks. Okay, thank you. So the next section is about the stuff that's in the last section, so it doesn't necessarily fall into DNSOP. And the question for all these are like, do DNSOP care at all? If not, they will go as a ISC into the submission editor queue. Let me switch the slides and so much clicking.
Is this the first time that we have a liaison section in DNSO?
Yep.
Yeah.
Okay.
Okay. In that case, I would like to express my appreciation for that, and I also to having the honor to be the first one. Yeah, it's a long title, a bit of a mouthful, but it's really actually a very simple concept, and there are no camels involved. So let me try to explain it very briefly for the sake of time. What am I talking about? It's a draft, and it's nothing more basically than putting a digital for sale sign on a domain name. And we thought about that for a little bit, so we had some design principles. We wanted to be lightweight and easy and simple. And in order to explain what it is, I figured let's talk about a real life example. I work for SIDN. We are the Dutch registry for the top level domain.nl. And we use this in production, well, more or less in a pilot state since 2022. So a typical use case, somebody has a good idea, has a domain name in mind, usually comes to our website. We have this who is page, what is actually aired up, but we still call it like that. Type in the first choice name, and then only to find out, okay, this name is already registered. So there's no way really to show whether or not that domain name, even though it is registered, could be up for sale. And that is basically all that this draft solves. So by using the methods described in the draft, we at SIDN, for example, but again, this is just one use case, we are able to show a for sale button. And the visitor can click on that button and is redirected to a landing page. In our case, the landing page of a registrar, and the registrar sees the domain name, and the two can get in touch with each other, and that's where our involvement ends. So, like I said, when we did this, we thought this through together with our registrars. We implemented it, and then I figured, oh, wait a minute, this could evolve in something bigger. This could be of use to a broader community rather than us and our registrars. So that's why I wrote the draft. So the design goals are to make it accessible and acceptable, and well, there are some nice words about balanced supply and demand. If you want to understand what I mean by that, I recommend you read the draft or the blog that we have posted recently, and I have a URL of that at the end of the slides. In a way that is universally applicable, and also we thought a little bit about ethics, because after all, we are also talking about domaining and drop catching and everything, so we thought about that as well, and it's all explained in our blog and in the draft as well, even with an ethical considerations section. And also, last but not least, we don't want to be really involved as a registry. We are happy to bring a seller and buyer in touch with each other, and as far as we go, our involvement ends right there. We don't want any commercial entanglements or whatsoever. So those are the whats and the whys. Now, very briefly about how does this work? Well, very simple. It's a text record under a special underscored label. We call it underscore for sale, but it also applies to lease constructions or selling the right to use a domain name, which is the case in .nl. And this is what it looks like. So it's structured. It's described in the draft what the fields mean. In this example, you see an asking price of $500 and an email address that somebody can send an email to get in touch with the seller. For the example I showed in the previous slides, we use a little bit more of a different method with a hash that translates to this landing page. All of that is possible and described in the draft. Here are some other examples, telephone numbers, URLs, even some free format text. This also works for domains that don't even have a public registry, or you could even use it for separate labels in a domain name, should that be a use case for you. I have some running code, so there is a demo. You can use it with your own domain name, test a little bit. It's a bit of a syntax checker, so it shows what are the good records and which are invalid. Again, oops, my screen went dark, but am I still there? Yeah. So the version 11 of the draft, there it is on data tracker, but I'm working on version 12 on my personal website. I recommend you to read that. It has a few improvements, and I'm planning to publish that draft soon after this IETF meeting. The reason why I'm here is there was a DNS Directorate review. The review basically said it is technically sound. It doesn't really influence the DNS protocol. No changes are required in DNS software. But the reviewers saw the potential that we see as well. So there was a recommendation to bring this to the DNSOP working group, either for standardization or for community discussion, at least. At the moment, it is in the independent submission stream, and I'm more than happy to keep it there if that is also doable and works fine. We had some questions about IANA registries, but those are ironed out. So it should be doable also to run it through the independent submission stream. I'm not sure, whichever works best for the experts here. That's it. Here's the blog. I recommend you to read it. And that's all I had to say. And I'm really interested in guidance from this group, advice, recommendations. And I'm eager to move this forward. It's almost done. It's pretty mature. And I would really see this published as an RFC, because then we can do outreach to our colleagues and other registries, like maybe this is something for you to use. Thank you.
Thank you. So just a comment from me as a chair that the DNSOP already has too much work. So think hard before you just say this belongs to DNSOP. I don't think this belongs to DNSOP. I think this is fine as ISC. And I think it doesn't need IETF consensus. It needs a consensus between the RRR model, the registry. So it's more in the ICANN space than IETF space. John, go ahead.
Yeah, I was going to say more or less what you said. I mean, technically it's fine. Marco and I have gone around with this several times, and there's some minor technical things that I would have done differently, but he quite reasonably said that, well, we have running code, and I said, yeah, it's fine. So if there were a lightweight way to run stuff through DNSOP, I would prefer to do that, because then the registry could be an IANA registry. But I'm with you. It's like given the stuff on our plate and the fact that it's it doesn't actually do anything in the DNS. It's just a way of publishing a flag. I think that leaving it with under the circumstances, leaving it with the ISC is fine, and that will let them do what they want to do and publish the flags.
Or not do RFC at all.
No, I think it's useful to be an RFC, because it's a thing in the DNS, and it's where people will also there's a lot of people at ICANN who would be interested in this. Being able to point to an RFC gives it considerably more credibility, even making it clear that it's an ISC one.
Exactly that. Thank you. I agree with that.
Tobias Siewich, Max Planck Institute for Informatics. I'm basically fully in line with that. I think this is to a degree the wrong community to make any meaningful contributions to that, because it is mostly a thing for the people, selling domains, registrars, domain parkers. I believe it could be useful for them. I don't know whether they would adopt it. I'm pretty sure that having an RFC describing this will make them more likely to adopt it than not having it. So I think this is nothing DNSOP really has to poke into. You know what you're doing, and well, it's straightforward.
All right, thank you.
Okay, Elliot.
Elliot Lear, Independent Submissions Editor. This comment goes to not only Marco's draft, but other drafts in general that are hitting this group or hitting me. The way it's up to DNSOP and the IETF to decide what they're going to make an RFC, right, and go through the standardization process through that path. If it comes to the independent submissions editor, the process will be that I will seek expert review. Everybody in this room has spent a lot of time on DNS issues, and your reviews are more than welcome. Especially whether you think the idea is a good idea, if you'd like to see some changes, please feel free to comment on the draft to the independent submissions editor at rfc-ice@rfc-editor.org. And as I said, this holds true for the first, since I'm not going to take the mic again, I'm just going to go through this once. This holds true for this draft, the one we're going to talk about next. And should .internal come back to this group for further review, or to me, the same thing holds true. I will say that the IETF as a whole should take serious consideration as to where rough consensus can help a piece of work, where the dividing line is. To that end, I also want to advertise the mailing list that has been set up by Wes and Med, dns@ietf.org, in terms of how work is organized. The ICE is paying attention to that. I'm not going to have a substantially large amount of contributions beyond what I've already said there, though. And so I'm looking forward to how the IETF decides to continue on that.
Thank you.
Yeah, we're done. I was interested in hearing Joe's opinion, but I'll see you in the hallway.
Right, our next speaker. So.
Hello everyone, my name is Jiankang Yang from Cynic. I'd like to introduce thank you for giving me the time to introduce the draft. This is a method for identify the administrative boundary of DNS names. Okay, so the idea is simple. For example, currently we have Tsinghua University and a simplified version and a traditional version. So for Chinese can easily recognize it, but non-Chinese may not recognize it. But for the application also doesn't recognize it. For example, the .tld, .china traditional version, simplified version, actually for Chinese is the same, but the application doesn't know it. So we like have a DNS method to let the application know where the .china simplified version and the traditional version actually is controlled by the same DNS administration team, or the second level, Tsinghua University simplified version and the traditional version actually is controlled by the same administration team. So we have a say, if it's in such a weak course, they have a relationship or share same administration boundary. So this idea is tried in, I think, 10 years ago in IETF debug working group. So this, but the working group failed. So there's a working group chair at that time suggest if you want to pursue the future application, maybe through ISE. So we, the debug also tried another time in 2023. So there's a both, but also the both conclude without creating a working group. So I like, because they are now in ICANN new GTLD, scenic, we have a lot of IDN names. So when I try again, so through the problem we already explained. So we have with domain names, so for example, Chinese word domain names 1 and word domain name 2. They let application to know these two domain names, A and B, so share the same administrative boundaries. So current DNS lack a method to identify the administrative boundaries between these domain names A and B. So also, I think it is the future. If we extend the scope, so we can use it for new GTLD variants, because in this round of GTLD program, there's a lot of GLT variants, the TLD. So maybe they can use the method too. So currently we use design new RR type framework. This is a framework, so there's a anchor. But it is too a little complex in detail, so we are neglected. Then go to the example. So these are algorithm. So maybe if you're interested, you can go to the detail of the draft. Actually, this is an example. For example, A and B. A dot example and B dot example, they let the administration applications to know they actually share the same administrative. They can use the debound working set list DNS record, and also they can C dot example just the intermediary domain names. Also, they can also as a B dot example as a example or intermediary or as an anchor name. So this is this photograph shows how to works, how this works. Now we want to A dot example and a B dot example to let the application to know they actually share the same administrative boundaries. So first, A dot example have a DNS record dbound 1 point to C dot example. So C dot example as an anchor name or is an intermediary. So B also pointed to C dot example. So to confirm, C dot example in his record in his DNS record point dbound 2 A dot example 2. A dot example and P dot example. So they pointed to A dot example and B dot example. So through such method, so the application will know A dot example and B dot example will share the same administrative boundary. So this method, so we can give the user application opportunity through DNS method to found A dot example and B dot example actually share the same DNS administrative boundary. So this is a basic idea. So the question is because we is ISE publication, so new R type is expensive. We also use instead of apply to use debound new R type. We may use in next version we use debound as a prefix for special TS record. So I think this is easy to be implemented. So so I like to continue with the ISE stream currently. Thank you.
Thank you. So I have a couple of comments and one question. So first of all, RR types are not expensive. So they can go through expert review.
Okay, thank you.
So they are not expensive. But my other comment is like you said, there was a debound, it concluded without doing anything. There was a debound 2, it concluding without doing anything. It feels like that, like the idea was thrown out of the door, then window, and then you are trying to fit through the chimney right now. And it feels wrong to me because IETF clearly didn't came to consensus to continue working on this. But my question is, this is not really about DNS. This is really about the application. So are there any applications that are really interested in doing this? So I think this should be like, you should gather support from the applications, so from the application area, that anyone is actually interested in doing this, because I think this is a huge can of worms. Like, what happens if one domain falls out and is registered by another, and there's a still debound record at the first domain? So this has a security implications, and I don't want to even think about these. But I don't want to discuss this here at the DNSOP. But I think you should like go to applications and continue with the idea only if there is support from the application that would actually implement this. That's my stance on it. Okay, Tobias, you're next.
Tobias Siewich, Max Planck Institute for Informatics. I personally do see theoretically the use case. However, I would argue that DNS is tree-shaped to cover that use case, and not using the tree-shaped nature of DNS, which then creates the issue that is tried to be solved with this draft, is more of a social problem than a technical problem, and trying to capture that with a technical solution will just cause pain.
Victor?
The TLD issue is already solved with DS records. The speaker is probably aware that Taiwan has two different TLDs. One is a DS record for the other. So that problem has a solution. And as for applications, my sense is that what makes an equivalence for one application may be inequivalent for another. I don't see a likely solution where administrative domains make the same, in a sense, to all applications. So I don't see this as a DNS thing at all.
Yeah, just what I said in the chat is, I mean, Yao is right that this is a problem we've been thinking about for a long time. But I mean, I look at the draft and I just don't see this as moving things ahead. I mean, for a decade, it's been possible for mail servers and web servers to auto-configure to deal with variant names. Nobody's ever done it, which suggests to me that this is not a problem that people think is worth solving.
Okay. Anyway, thank you for presenting this. It's okay. That's it. We don't have any more comments. Last presentation, Joe.
All right, thank you. I'm presenting on behalf of Swapnil today since he had to travel for another conference. So I got my notes here and I will do my best to be Swapnil. All right, so DNSSEC has been around for a while with the current RSA standards that were published in 2005 and then later the elliptic curve standards coming along. There's been a bunch of presentations at IETF and other forums about the risks of post-quantum, so I won't go through all that with regard to DNSSEC right now. But we do have a challenge, and the challenge is that for the community, with these new algorithms are going to require wide adoption, global coordination, and they're not exactly perfect fits for DNSSEC. So there's going to be some things that need to be addressed in the transition, engineering and operations wise too. So we need to do some things to make sure that DNSSEC remains secure and viable. Overall, on PQDNSSEC, there's been collaboration across the community, some efforts to span research, experimentation, presentations, hackathons, things like here at NIST, DNSOARC, and collaborations with academic entities. IETF is responsible for DNS and DNSSEC standards, and the PQDNSSEC mailing list and the side meetings have been productive venues. Thank you to the many people in this room who have come together at those meetings to share your evaluations of PQC algorithms, your implementation experiences with algorithms, resolver behaviors. et cetera. And especially thank you to Peter and Caspar for their leadership in that group. The IETF hackathons and some individual experimentation have also been really helpful in looking at these PKC algorithms. Especially thank you for Bind for Andre, NSD for Willem, and for Javier and Andrea for their core DNS implementations that support these algorithms. We were able to get some real world data that we presented at the PKC DNS implementation at IETF 123. So we've been able to actually get some metrics and compare things. Overall, NIST annual PKC conference has been a very valuable opportunity for cryptographers to come together. That's why VeriSign picked that, where we first presented our MTL mode implementation or standard idea. We've continued to engage them through panels on pre-hashing, presentations on strategies for PKC DNSSEC that support their ongoing evaluation of additional algorithms. And some of those algorithms that they're now evaluating may also be useful long-term for the routine performance choices. Again, we've worked with a bunch of academic universities, University of Carlos III in Madrid, University of Ostrava, University of Twente, Virginia Tech, the University of Waterloo. We worked with SIDN Labs to do some feasibility studies, make the experimentation possible for the MTL mode. VeriSign published our internet drafts and released our open source code. By publishing the drafts and making the code available royalty-free, we've been supporting the independent testing and validation of this as well. And finally, last but not least, the DNS operator community has had a large stake in this, and we were able to take this to DNSORC recently for further discussion among the operator community. So this ecosystem approach, spanning the research, open source, standards, and operator feedback has really helped us to ensure multiple perspectives are available to shape DNSSEC. At the IETF 123 PQ DNSSEC side meeting, there was agreement to create a draft to talk about the strategy for PQ DNSSEC. The first version of that strategy has been published, focusing on crypto agility and security. The strategy includes two classes of algorithms, one that gives resilient fallback in case there's issues, and one that gives routine performance to allow us to use some high-performing algorithms. The strategy draft also includes discussion of some techniques to reduce that impact in PQC, like MTL mode. As I mentioned, then we've presented this. We went to the NIST 6th PQC conference and presented on the strategy, as well as DNSORC, talking about the measurements to support that. Okay, so that kind of brings us to the question here, which is, where should the work for PQ DNSSEC fit within IETF? There are already some drafts that have been submitted. I know VeriSign has done 3. I'm sure there's going to be more in the community, like dynamic signing for PQ DNSSEC. And these drafts will cover a variety of things, not just new algorithm IDs, but also changes that need to go with the protocol to mitigate some of these impacts. And so the question is, where do these things need to go? We previously approached CFRG and plants, talking about defining Merkle tree constructs and hash operations, and they weren't very interested in that. DNSEXT was once a home for DNSSEC mechanisms, not just talking about algorithm IDs, but also looking at things like NSEC3 and the hashing schemes for that. In the recent DNSOP mailing list, there were some comments about needing cryptographic review, possibly for some of the upcoming drafts in this area. So do we need a working group to work on some of these topics? Do we need to bring in more cryptographic expertise? So in conclusion, there is plenty of work that needs to be done in the near term for PQ DNSSEC. Given the challenges from quantum computers and their general guidance for things to be post-quantum safe in the coming by 2030, we need to figure out where this work could be standardized. It may be here in DNSOP, maybe a new group like DNSEXT who did the NSEC work, or maybe some combination of the group. So overall, that's all I just wanted to present, and now I want to feedback on the idea of where this should go.
Paul Hoffman, very cognizant of the fact we only have 2 minutes regardless of what the timer says. This is a great draft. I think it should be somewhere. If Wes didn't exist and we weren't thinking about these things, I would say it should be here. I strongly suspect where it ends up will be a product of the DNS at IETF work. It's really good. I would have one caveat though. You use the word migration in the draft. Be very clear that you're talking about migrating within the standards organization, not how should other people migrate to it. For those of you who weren't at PQIP yesterday, there was a universal decision that PQIP should not be covering migration, and I believe you shouldn't either. And I think the draft is, the rest of the draft, which is like 90% of it, is actually very important.
Thank you.
Flow and Observer was at the, I suppose it was a BOF a few years back about PQ and DNSSEC. And the feedback was from the ADs, hey, you have a bunch of work to do, but you don't actually know what the work is. So that's why you can't have a working group. So maybe someone should write down what the bunch of work is. So you have a draft here that solves a bunch of stuff, but there's nothing, these are the problems.
Thank you.
Kaspar Schutijzer, SRDN. Yeah, I think, yeah, I'm about to say the same as what Paul Hoffman said. I think it belongs somewhere, but yeah, I'm not sure if it belongs here necessarily. I don't think I can make that call, but something like that would make sense. Thanks.
Thank you.
Andre. So I was thinking maybe this might be a separate like focus group because it needs a different kind of people. It needs some cryptographers, it needs some DNS people. So it might make sense to have a own working group on this, but I think DNSOP would be hard group to get this through. Anyway, that's my last comment. Thank you. So thank you all for coming here. Thank you all to bear with us. Just one quick comment from the chairs. We plan to make some changes on how we accept the presentations and how we accept the drafts and stuff. We will announce it on the mailing list, and we will have an open discussion on what works and what does not. But we plan to implement some changes before the next in-person IETF. So expect an email from the chairs to the mailing list and expect to discuss what you do think about this. Have you all a safe trip home? No, I did. I did. Yeah. Paul. Paul. Next time.